Hi, my name is Evan Strebe, and my project is on herd behavior. So what is herd behavior? Herd behavior is when people are acting as a collective without a central authority. It's kind of like pack behavior, but instead of like a pack, they don't have an alpha. There is no real central authority. People are just influenced by any person's actions, random actions. But they work as a group. So why does herd behavior matter? Well, it can matter for two different groups of people. It can matter for, let's say, consumers and regular people for understanding how they're influenced on a daily basis by other people's choices, their peers, etc. But for businesses, it can help for crafting good marketing campaigns, and it can help to utilize the popularity of a good to increase the sales by illustrating that they are the superior good by people's preferences. So what was the premise of my experiment to test the whole herd behavior question? First, I needed to find a public area with lots of people. I needed to establish a large enough control group, and then another separate group for the experiment, the treated experiment, where I would try to alter their choices. What did I choose? I chose candy as my incentive. It's relatively cheap. People like candy. There's variations, and I could have a significant amount, which I felt would bring more people in than just a survey over their opinions. So the point of it was to show false peer preference and see whether that would influence their decisions when compared to the control group. So that was the basic idea of the experiment. And so here are the results from the experiment with percentages. In my control group, in about 2 hours, I got 31 people to stop and take candy. The overwhelming favorite was Kit Kat, with 45%, a little over 45% of people choosing that. Dove was about 23% of choices. Twix was 16, Rolo was 6, Heath was 6, and we had one guy who came in and said he had no preference, which wasn't very helpful, but we tracked it anyway. So those were the percentages of the controlled. Now afterwards, I had to think, well, you know, if I put percentages up, like let's say Kit Kat at 40%, I'm not really going to see a difference. So I needed to calculate these after I finished the control and come up with percentages that would be so different, I'd easily be able to see whether there was a change in people's behavior. So for the experiment, Kit Kat fell nearly 20%, Dove fell 12%, they were favorites, so of course I listed them much lower. Twix, which I had advertised to the people as the now favorite, the favorite of the people before them, jumped over 20%, up to 36.8. Rolo stayed about the same, and Heath, which I said was the second favorite, jumped about 12%. We also had one no preference, and the survey was 38 people rather than 31, but there were significant changes in just about everything but Rolo, which was very interesting. So what exactly happened? So we had 31 and 38 that went into the experiment. One in the control was no preference, one in the regular one in the treated part of the experiment was no preference. We could probably discount them. I kept track of them because I thought maybe being the first person to say, give us an answer and say no preference, it might become an important statistic. But as for testing this, it was not an option. The people weren't given the impression that they could say they had no choice, so I kind of disregard it for the math side of this. Now I represented the candies that were popular as significantly less popular, and the percentages that I used exactly were 40% for Twix, which I said became the favorite in the treated, 25% for Heath, 13% for Kit Kat, 12% for Rolo, and 10% for Dove. So if we go back here, you can see that, for example, Dove, which was shown as 10%, actually came into the 10%, 10.5% of choices were there, dropped significantly to that number. Kit Kat was still well more than the 13% that I put it as, but being such a heavy favorite, I really did not expect it to get that close to 13% anyway. I just didn't want 40% again. What's interesting though is Twix jumping 20% almost did make it to 40. So Dove and Twix coming up to the numbers that I was looking at. Heath getting close to 25%, tripling the amount that it originally was chosen. That was very interesting. So the question became, what was the total effect, right? Not only like did I have influence, it seems pretty obvious from these percentages that there was an influence. I still had to prove it, but the next question came in, were the people following the numbers that I put down, which was not something I anticipated as being a question when I originally set out for this. So I performed a chi-square test, and these were my two tables that I used for the test. In both of these, for my observed, they're identical. It's just what I observed in the actual experiment. My sample size is 37 because I'm discounting the one person who has no preference. So we had 37 actual choices. So it goes, 10, 4, 14, 2, 7. It's the same on both of these. These decimals are here because in the sample size of or in the control group, I should say, which was my expected for my first chi-square test, I had 30, not counting the no preference. So what I did was I took the percentage of choices that people used, multiplied it by 37, so I'd have the same sample size, the test would run smooth, and it gave me decimals that added up to 37 for the approximation of what people would have chosen had I had more people, right? So that's why you got these decimals here. In the second test, I took the percentages that I illustrated. So for Kit Kat 13%, for Dove 10, for Twix 40, etc. And I multiplied that by 37, like 0.4 for 40% by 37 to get these decimals in my expected column. So what were my hypotheses? For both tests, they were the exact same hypotheses. It was that the observed and the expected had the same results. That's my null hypothesis, right? That's what you would think would happen. My alternative hypothesis was that they had different results. For both of them, because there were 5 choices, I had 4 degrees of freedom, and I chose the alpha value of 0.05 as a relatively standard margin of error. So here were my results. So for the first test, my chi-square number was 23.878, which is pretty significant, illustrating the change that it had. My p-value, which would be related to the alpha value of 0.05, was 8.45 e to the negative fifth, or 0.0000845. That is significantly lower than 0.05, which would prove that there was an effect in the first instance. Now for the second test, which I was testing whether people were going to the numbers that I provided, my chi-square value was significantly lower at 7.51. My p-value was 0.111, which is greater than 0.05. The interesting thing about these p-values, though, is if I had chosen a different alpha value, instead of 0.05, I had chosen 0.01 because I wanted to be a little bit more certain, or even 0.1. Both of these would result in the same conclusion, where in the first, I am refuting the null hypothesis that there was no effect. There clearly was an effect that took part on the consumers in the experiment. And for the second test, I cannot refute the null hypothesis, being that there was, that they weren't going to those numbers, they weren't coming to the numbers that I had put out there. So that was my project. I thought it was very cool. It was nice working with people, out on the street. But I had a good time. People like candy, and I thought this was a really cool result. So, hey.